This video is about my visit to Shanghai, China for presentation of my research paper entitled Comparative Performances of Micro, Macro and Nano Softeners in the 12th Asian Textile Conference. Asian Textile Conference is arranged every 2 years by Federation of the Asian Professional Textile Association, that is FAFSA. It consists of 7 professional associations of Asian countries to provide a common platform to the textile scientists. ATC 12 was arranged by the Chinese Textile Society at Donghua University, Shanghai, during 24th to 26th October 2013. Objective of this study was to compare various forms of silicone softeners available in the market. The silicone softeners are very popular for finishing of cotton fabric. They are available in macro, micro and nano form, varying in their respective particle sizes. These 3 types of silicone softeners, macro, micro and nano, were applied on plain woven cotton fabric by padding technique. Then the changes in physical properties of the 3 types of finished fabric were measured and compared. Mn liquid was used as macro softener having particle size 150 to 300 nanometer. Then Serapalm 3P liquid was used as micro softener having particle size around 40 nanometer, and then AC1 Sandosperm oil liquid was the nano softener used having particle size less than 10 nanometer. All these 3 softeners were made by the then Clariant India. The method of application: the cotton fabric scoured, bleached, was padded with respective softener solution 100% pickup and dried, followed by curing at 150 degree for 3 minutes. The solid content of the 3 softeners, 3 types of softener used were different. Macro having solid content of 11 grams per liter, micro 81.8 grams per liter and nano 93.6 grams per liter. So while preparing solution, 3 nano solution having 10 grams per liter, 20 grams per liter and 30 grams per liter nano softener were made. While for macro and micro, corresponding solutions were having solid content for macro, it was 11.44, 22.88 and 34.33. While for micro, the corresponding solutions were having solid content grams per liter solution at 85.09, 170.18 and 255.27. Of the finished fabrics were measured in 2 ways. First is the drop collapse test. In this, according to the AATC test method 79 of the year 2000. In this method, a drop of water is allowed to fall by gravity on the fabric, and the time required to collapse the drop was noted. For untreated fabric having no softener, time required was 1.5 second, while for nano used 30 grams per liter nano softener, time taken was 3 seconds, while for macro and micro it was more than 5 minutes. So that means nano softener does not affect the hydrophilic property of the fabric much, while macro and micro softener make the fabric hydrophobic. The figure 1 shows the effect of concentration of nano softener versus wetting time. The wettability decreased linearly but very insignificantly with concentration. The coefficient of correlation between concentration and collapse time was very high. The coefficient of correlation was 0.95. For micro and macro softener, finished fabrics were made hydrophobic. Way To measure the hydrophilic property of the finished fabric was shrinking test as per BIS standard 2369 of the year 1967. In this method, no instrument is used. The 1 gram fabric was folded into 5 centimeter into 5 centimeter and then allowed to fall freely on water surface. Time required for sinking of the fabric into the water was noted. For untreated and the 30 grams per liter nano softener treated, the time required was same, around and very short, that is around 2 seconds, while for micro and macro it took near about 1 minute in all concentration. So this shows that the surface characteristics of the untreated and silicone treated are more or less similar, while the macro and micro finished fabric, they are having hydrophobic character. They change the fabric properties from hydrophilic to hydrophobic. The figure 2 shows the effect of softener concentration versus the sinking time for all three property of the finished fabric. The test was according to ATTC method number 66 of the year 2003. In this method, the fabric is folded and kept under certain weight for a particular time, and then the weight is lifted and the angle at which the fabric recovers is noted. If the angle of recovery is 0, that means no recovery, very poor, there is no crease recovery. But if it is 180, that means complete recovery. In most of the cases, it is between less than 180 degree. So in case of with finished of all three softeners, crease recovery property was improved as compared to the untreated fabric. The maximum recovery was with macro and minimum recovery was nano. The crease recovery angle is directly proportional with the concentration of the softener. At lower concentration, crease recovery angle was much higher for macro and then micro and nano. At higher concentration, crease recovery of macro and micro were very close. The relation between the softener and the concentration was more or less linear. In case of micro, coefficient of correlation was 0.996 and near linear. In case of nano, it is 0.97. For macro, maximum crease recovery angle was obtained at 20 grams per liter concentration of the softener, and then it lowers down. That's why coefficient of concentration, correlation of coefficient of concentration and crease recovery angle was poor in case of macro, and it was only 0.78. Macro has higher surface deposition and having higher bending rigidity as compared to the two other softeners. The figure 3 shows the effect of concentration versus crease recovery angle of all three softeners at all three concentrations. Stiffness of the untreated and finished fabrics were measured by bending length apparatus. In bending length apparatus, the fabric is allowed to fall on the end of a plate, and the length of the fabric required to form a 45-degree angle of bending is noted as bending length. Higher bending length means it is more stiff. Now, flexibility of yarn and fabrics increases with softening. That means bending length goes down. So, the untreated fabric is the stiffest one, followed by macro, nano and micro finished fabric. Waves showed higher bending length, that means having more rigidity. Bending length is inversely proportional with the concentration, as it can be shown in the figure 4, where it is shown the effect of softener concentration on bending length. Now, for all softener, for overpan wave, the correlation between bending length and the concentration was linear, and coefficients were very high. Coefficient of correlation was very high, from 0.9 to 0.99. Exception was one for nano warp. Macro finished fabric, surface deposit, the surface is smooth. Micro is a combined effect and balance to render lowest bending length, that is more softened, more flexible. And nano penetrate inner, so no surface modification. So it is very similar to the unfinished fabric. Another measure of fabric stiffness, drape is measured is a drape meter, where fabric is allowed to fall, kept over a circular disc and allowed to fall freely. If the area of the shadow under the disc is higher, that means it is more flexible and drape is high. While if the area of the shadow is similar to the plate, that means it is stiffer. Now, it is the measurement was made as per BIS standard 8357 of the year 1977. Drape coefficient was lowest for micro, followed by nano and macro. Micro softener make the fabric most flexible. Drape coefficient is inversely proportional with concentration, as can be seen from figure 5. For micro and macro, coefficient of correlation between drape coefficient and concentrations are high, 0.99 and 0.97. For micro, rate of decrease of drape coefficient with concentration is highest. For nano, the rate of decrease is lower, between 20 to 30 grams per liter, resulting lower coefficient of correlation of 0.83. The trend is similar as bending stiffness. Means pulling apart of a fabric into pieces by pulling force on two sides. Now, tearing strength is for warp, it is proportional to concentration. The tearing strength increases with concentration. Increase is highest in case of micro, followed by macro and nano. The coefficient of correlations of tearing strength and concentration are 0.96, 0.95 and 0.94 for macro, micro and nano softeners respectively. For weft, the correlation is comparatively poor. For macro and micro, coefficient of correlation between the tearing strength and concentration is poor. The coefficient of correlation is about 0.75 and 0.70 for macro and micro. The increase is rapid up to 10 grams per liter, and then after they change very little improvement. Nano, the increase is much lower, up to 20 grams per liter, but linear correlation is high, that is around 0.93. Fabric lubrication is predominant in case of macro and micro, facilitating grouping of yarns and subsequent increase in tearing resistance. Then the same in case of nano softeners. That is the strength loss during rubbing or abrasion. It was tested in a flat abrasion tester using denim fabric as the abradant. The method was BIS 12673 of 1989. The softener lubricates the yarns and fabric and reduce interfiber friction. Hence, strength loss during abrasion resistance decreases with softening. Percentage strength loss decreases with concentration, but has 20 grams per liter reverse trend observed in a few cases. Average strength loss for warp and wave highest in case of macro and lowest in case of nano softener. Macro finish fabric shows higher strength loss, indicating severe disintegration of the yarn assembly than the same in case of micro and nano. Poor correlation observed in few cases like nano warp, nano weft and micro weft. The figure 7 shows strength loss before and after 3000 cycles of abrasion. Statistical significance of varying concentration and softener was tested with 2A ANOVA, and it was with taking example of keys recovery angle of warp. It was found with concentration, in case of concentration, F actual was 21.9, which exceeds the standard table value of 4.76 at 0.05 level of distribution ratio with the corresponding degree of freedom 6. In case of softener, F actual was 7.9, which also exceeds standard table of 5.14 for the degrees of freedom 6 respectively. Hence, the variation with concentration and softener time are considered to be significant. Of the fabrics or the relative softness of the 9 finished fabrics was assessed by 10 observers by ranking experiment. The following ATTC evaluation procedure 5 of 1990. The base soften was as numbering 1, marking 1, ranking 1, and the worst as ranking 9. So, if the table can be observed that first position is almost everybody accepted that in nano softener 30 grams per liter is the best one. The second one was also nano softener 20 grams per liter nano softener, but there is a little confusion between 10 grams per liter nano and 30 grams per liter micro softener. If we see the modal rank, the first rank is 30 grams per liter nano, then second position 20 grams per liter nano, and third there is a confusion as they are very similar. Is third is average modal third is 30 grams per liter micro soften and 10 grams per liter nano soften. If we see the total rank, the rank of for there is no confusion for the first and second rank, but for third rank is total rank is for 30 grams per liter micro and 10 grams per liter nano are very similar, 45 and 44. So there is little confusion. The relative softness measured by 10 judges has now we can conclude from that this nano was found to be softest and micro intermediate soft, macro least soft. Even for each softener, 10 grams per liter was poorest in softness, 20 grams per liter was intermediate, and 30 grams per liter was best in softness. If we see the figure 8, which shows ranking of softener treated samples before and after washing for 2 hours, it can be seen total ranking has not changed much. That means softness is in all the cases are quite fast. That the ranking made by 10 observers are very in close agreements, but whether it is due to by chance or statistically significant is studied by coefficient of concordance of Kendall. It measures the degree of agreement for total n objects among m judges with the formula W12S by m square into n to the power 3 minus n, where W varies between 0 and plus 1. Now, it shows that judges are more in agreement, had more conviction in their verdict. Significance of W tested with reference to F table. Prior washing, F actual was 18.27 with degrees of freedom of 9 and 72 was well above the 1% level of F table value, that is 2.78. After washing, F actual is 141 with the same degree of freedom, which is much higher than the same table value. So in both cases, 10 judges were nearly in close agreement, and the closeness is not due to chance. Finally, we took the surface photographs of the treated and untreated sample in scanning electron microscope. Figure 9 shows the ACM photographs of untreated and 30 grams per liter macro, micro and nano softener in figure A, B, C and D. Now from the figures we can observe that macro softener deposits more on the surface, micro softener treated sample roughest surface, nano softener treated samples or smoothest surface. Micro softener treated sample shows a phenomenon intermediate of micro and nano treated samples. Nano softener penetrates into the fabric mode. Conclusions. Wettability. The fabric becomes substantially hydrophobic by macro and micro softener, marginally by nano. Hydrophobicity increases with concentration. Rate is high for macro and micro, low for nano. Crease recovery improvement. Micro shows highest improvement, macro moderate improvement and nano lowest improvement. Flexibility, that is bending length. Untreated is the stiffest one, followed by macro, nano and micro. Because macro shows surface deposition, nano shows penetration, micro some sort of combined effect and probably strike a balance to render lowest bending length. Drift coefficient, the observations have similar trend as in bending length. Tearing strength, increase is highest for micro softener and least for nano softener. Strength loss due to abrasion. Strength loss is highest in case of macro softener and lowest for nano softener treated samples. Subjective evaluation of softness. The 10 observers concluded that macro is the least soft and the nano is the most softest, and the softness increases linearly with concentration. Durability to honor. Macro is least durable to washing, micro is medium durable and nano is most durable. Scanning electron microscope photographs confirm that the macro softener mostly deposit on the surface, while the nano softener penetrate inside the fiber and micro softener takes up an intermediate status. Softeners having particle size of 150 to 300 nanometer mainly deposited on the fiber surface. Average pore size of cellulose is around 10 nanometer. Nanotypes softener also have particle size less than 10 nanometer, so they can easily penetrate into the fiber and very little they deposit on the surface. Micro softener having particle size of 40, so they take intermediate positions. Some particles micro softener they penetrate inside the fiber, while a good amount deposit on the surface. This has been shown schematically in a diagram. Yellow colored fiber fiber is in yellow color. Macro softeners red color mostly remain on the surface. Pink color micro, they penetrate partially into the fiber, and nano, green color nano particles, they mostly penetrate into the fiber. Little deposit on the surface. This was published in Textile Institute Journal. Reference is given.